Oh my soul. All right. Grade 10. I hope you guys are well. Today we're just going to actually revise, guys. Revise. Grade 10s, we need to be in revision mode right now because March control tests are coming up very soon. Okay. And I'm giving you guys my time and attention. These precious and beautiful grade 10s. So yeah, let's revise all the way. Let me just, sorry, I just want to quickly share. Yeah, okay. So yeah, grade 10, I hope you're good. I hope you're very well. So we are going to look at some grade 10 questions here. Just a sec, I just want to find them. I want to find them, these questions. Yeah, here they are. So we are going to look at some of these questions, guys, and we are going to answer some of them. So we are going to start right there. Question 1. There's a simplified kind of type of question here that you can see. Factorize 2 factorized questions, and then we are going to look at some simplified type questions, as you can see there. So basically these are the questions we'll be looking at. I hope we guys can actually get into the swing of things, into the game of things. Please do double tap on the screen, share the live with as many grade 10 learners that you know that may possibly be struggling with mathematics grade 10, because grade 10, remember guys, laying the foundation for grade 10, 11, 12. So if you have a strong foundation in grade 10, it helps out a lot. So please do share the live with as many of your friends that you know that are in grade 10. Encourage them to share the live with their friends in grade 10. Let's all get in here. Like, it's Sunday evening, guys. We are finishing off the weekend and we are going into a new week. So we'd want to go into the new week at least with a bit more confidence than we usually have. Control tests for March, they are starting off very hard this next few weeks. You may probably be writing pure maths next week, so please, let's come in here and share the live, guys, with as many people as you can who are in grade 10 and who are doing pure maths. Okay, let's get them in here. So we're going to look at these questions, guys, as you can see them there on the screen. Simplify, factorize, a bit more simplification questions there that you can see. All right, and then as we turn over the page, we'll look at some solve for x type questions, as you can see there. Solve for x for grade 10, exponential equations, simultaneous equations, and that will be that for today. All right, for grade 10s. So I'm not intending to be here for more than an hour, and I'm not intending to be spending too much time explaining things. So hopefully you can also have your pen and paper out and you can answer the questions along with me, so that you can also refresh your mind and remind yourself of what you do know and what you don't know. Okay, welcome to everyone, by the way. All right, please do let me know in the comment section if I'm too fast or too slow, so that the pace at which I go can be one that is appropriate. Okay, so let's look at the first question. The first question says simplify 5a minus 2b into 25a squared minus 20ab plus 4b squared. So what we have here is a bracket with 2 terms and then a bracket with 3 terms, and these brackets are not separated by a plus or minus sign, but they are combined by a multiplication sign. So as Liam says in the comment section, we're supposed to use the distributive law. So let's write it down, guys. The question itself, 5a minus 2b into 25a squared minus 20ab plus 4b squared. So distributive law, guys. Distributive law. Remember, distributive law, when you distribute, you consider the sign, the number, the letter. As long as we are doing that, we should be fine. You multiply the sign, you multiply the number, you multiply the letter. So let's go. 5a needs to be distributed to negative to 25a squared. 5a then has to be distributed to negative 20ab, and then 5a needs to be distributed to 4b squared. That's how we do it, eh? So we are going to multiply, guys, and we are going to multiply sign first, then number next, then letter last. Sign, positive times a positive is positive. Number 5 times 25, that's 125. Letter, a times a squared. We keep the letter a. We add the exponents 1 plus 2. That's going to be a to the power 3. So that's the multiplication of 5a with 25a squared. We then now going to multiply 5a with negative 20ab. Same thing, sign, number, letter. Positive times a negative, negative. 5 times 20, 100. A times AB. Remember, the A and the A have the same base. So when you multiply the A and the A, they both have an exponent 1. You keep the variable A. You add the exponents 1 plus 1. What does Snoko say about 1 plus 1? 1 plus 1 for the exponent is 2. Then remember, the B, the letter B, is combined with a squared. And so it's 100a squared b and negative 100a squared b. So 5a times negative 20ab is a negative 100a squared b. We take 5a, we distribute with the last term. Same thing. A positive times a positive is a positive. 5 times 4, the number, is 20. A times b squared is ab squared. You combine the a and the b squared because they are different letters with different exponents. Just combine them when you multiply them. So we've just finished distributing 5a into these 3 terms, and these are the 3 terms that we get as a result of that. Now that we are done with 5a, we take 2b. We do the same thing with 2b. We distribute to all 3 terms. So negative 2b times 25a, you do the same thing. Signs, negative times a positive, negative. 2 times 25, 50. B times a squared. B times a squared, guys. That is a squared b. B times a squared. That is a squared, then followed by the b combined. You take the negative 2b, you multiply by negative 20ab. So we do the same thing. The sign, negative times a negative, positive. 2 times a 20, 40. B times AB. So B times AB, the A will stay. The B times B, remember B times B, when you multiply the same bases, what do you do to the bases? You keep the base, you add the exponents. Remember, there's an exponent 1 here and there's an exponent 1 there. So when you are multiplying same bases, you keep the base B, then you add the exponent. So what does Snoko say? 1 plus 1 is 2 Snoko. So it's AB squared. Then last but not least, negative 2b times a positive 4b. And negative times a positive is a negative. 2 times 4 is 8. That's the number. Then the letter b times b squared. B times b squared. When you are multiplying same bases, b times b squared, you keep the base. Then what do you do to the exponents? There's an exponent 1 there and there's an exponent 2. For the same bases, you keep the base, you add the exponents. 1 plus 2 is 3. So now I have, from the distribution, got 1, 2, 3, 4, 5, 6 terms. Now I am going to check after distribution if I have any like terms. Guys, what are like terms? Like terms are terms with the same alphabetical letter, or we call the same variable. Your alphabetical letters are variables. We call them variables in mathematics. So they are the terms that have the same variable and exponent. Okay, so if we look at negative 100a squared b, who is similar to negative 100a squared b? We're looking at a squared b. This is ab squared, so it's not the same as that. This is a squared b, so this is the same term as that. Why? Because they both possess a squared b, a squared b. Then plus 20 ab squared is the same term as plus 40 ab squared. These are like terms because they got a and a, same exponent, b squared and b squared, same exponents. Okay, and then lastly, the last term, negative 8b cubed. So if you look at now the terms that we can add, 125a cubed is alone, so we keep it like that. And negative 100a squared b minus 50a squared b, we can subtract these two, negative 100a squared b minus 50a squared b. What will that give us, guys? Negative 100a squared b minus 50a squared b. What does that give us? Those are like terms. When we actually resolve the addition and the subtraction of these two, what is the answer? Negative 100a squared b minus 50a squared b. I'm waiting for someone to tell me what's negative 100a squared b minus 50a squared b. Negative 100a squared b minus 50a squared b. What is the answer there, guys? Negative 100a squared b minus 50a squared b. Wow, Coco, thank you very much. Negative 150. So yes, guys, and specifically negative 150a squared b. Thank you. The a squared b doesn't change. We only subtract the coefficients. Negative 100 minus 50 is negative 150. Guys, if all else fails, just grab your calculator and punch in negative 100 minus 50. You will get the negative 150, and then all you do is you put the a squared b, because that does not change when you are adding like terms. Your variable and your exponents don't change when you're adding like terms, but the coefficients you add and subtract. Then we go on to 20, positive 20ab squared plus 40ab squared. What's 20ab squared plus 40ab squared? 20ab squared plus 40ab squared gives us 20ab squared plus 40ab squared gives us, thank you Z, I see your answer there in the comment section, 20ab squared plus 40ab squared, yes guys, plus 60ab squared. And then last but not least, the only other unlike term from other terms is negative 8b cubed. And guys, if you can look, there's no other like terms. So if there are no other like terms, it means that our answer basically ends right there. Okay, and if they are awarding us 2 marks, we deserve the 2 marks, because 1, we expanded 100% correct to get the first line of terms. Then 2, we added and subtracted the like terms accurately, so that deserves our 2nd mark. So this is a typical 2 mark, or sometimes minimum, maximum 3 mark question. You can't not expect any more than that. Okay, or sometimes it could be 4, but yeah, for this particular paper that I have here, this question was basically out of 2 marks. Okay, And it all was asking us to do what? To simplify that following. So let's look at the next question, because coming up is our factorization question. As you can see, the question says 4x cubed minus x minus 4x squared plus 1. Okay, 4x cubed minus x minus 4x squared plus 1. And we are asked to do what? To factorize fully. Factorize fully. As well as 1.2.2, 16a cubed minus 2b cubed. Factorize fully. The first question is for 4 marks and the second one is for 2 marks. So let's write the question. Factorize fully. What are we being asked to factorize fully? 4x cubed minus x minus 4x squared plus 1. So when we look at this particular question, we are like, okay, when we are factorizing, guys, what do we usually do when we are about to approach factorization, right? Those who have been in my live lessons for the longest time now have been hearing me say the same thing over and over again when it comes to factorizing. And that is what? Okay? And that is what? Okay? Let's see, who's this? Next time you are saying that 150a squared b plus 60ab squared can be added. No, we can't next time. We can't, because remember, for like terms, okay, like terms are terms with the same variable and the exponent as well needs to be the same. So if you look at the step above, negative 100a squared b is the same thing as negative 50a squared b when it comes to terms. These two, I wrote them in a rectangle, both of them, because a has an exponent 2. This a also has an exponent 2. This b has an exponent 1 that you can't see. This b has an exponent 1 that you can't see. So these are like terms. We can add and subtract like terms. So that's why negative 100a squared b minus 50a squared b gives us a negative 150a squared b. We can add them because the variable, the letters, and the exponents are the same. Plus 20ab squared and plus 40ab squared also are like terms. Why? Because look at this a. This a has an unseen exponent, which is 1. Likewise, this a does as well. This b has the exponent 2. That b also has the exponent 2. So these are like terms. So you can add and subtract like terms. You get 60ab squared. But these two, they are not like terms. Why? This a has the exponent 2. This a does not have the exponent 2, but it has an unseen exponent, which is 1. So because the a's have different exponent, we regard these two terms as unlike terms. We cannot add and subtract unlike terms. So get it into your mind and heart, and never forget this, that we can only add and subtract like terms. What are like terms? They are terms with the same exact variable and exponent. If they have the same variable but the exponent for those same variables are different, we regard them as unlike terms, and therefore we cannot add or subtract those kinds of terms. Hopefully that's clear. So that's why we leave our answer at this stage and we do not continue any further. We cannot say negative 150 plus 60 because the variables with their exponent are not the same for these two terms. Okay, so I hope that's clear. Thank you, Shadaroni. Is it Shadaroni or Shadaroni for the 2 roses? I really appreciate it. That contributes very beautifully and handsomely to my live goal. So thank you so much. You are very kind, and be blessed for the gifting. It is much appreciated, guys, when it does come. Yeah, if you want to buy my heart, you buy gifts. And plus, if there's questions that you have along the way based on other things that are in this context, maybe that I didn't touch on, be sure to type in the comment section. You're more than welcome to. So we're going to look at this question now that says factorize fully. Guys, when we are factorizing, as I was saying before I was interrupted, I was saying that with factorization, there are steps that we need to go through. I call these steps, or we call them, the golden rules of factorization. What are the golden rules of factorization? The first question you always must ask yourself when factorizing is, how many terms are in the expression? Okay, how many terms are in the expression? So if you look at this expression, how many terms do you see? Okay, you can comment in the comment section how many terms you see. I see you, Tim, that you are saying common factor, but just bear with me here. So how many terms do we see? We see 4 terms. There are 1, the minus sign separates, 2, minus sign separates, 3, plus sign separates, there's 4. So you guys are 100% correct. Applause for all of you. You deserve it like nobody's business. I'm so proud of all of you. So here, then the next question we ask, question number 2, is there a need to apply the sign change rule? Okay, I call it the SCR, the sign change rule. Should the sign change rule be applied in this expression of terms? Do we need to apply the sign change rule? If we do, we apply it. If we don't apply it. Then we move on to the next question, and that is there a highest common factor? You look at 4 elements when you talk about highest common factor. You talk about the highest common factor sign, the highest common factor number, the highest common factor letter, and the highest common factor bracket. Sign, number, letter, bracket, sign, number, letter, bracket. The highest common factor sign is always the sign of the first term. Highest common factor number, you look at the coefficients of the variable and you look at the number, that is the highest common factor for all the terms in the expression, however the number is. L, that's the letter. You look at the common letter which has the lowest exponent. You take that out if it's there. B, that's the common bracket. The common bracket with the what? With the lowest exponent. You also take that out if there is one. So we only take out what is there. Okay, sign, that is basically the sign of the first term. Number, the highest common factor of the coefficients of the terms. Letter, that is the common variable or the common letter with the lowest exponent. Bracket, that is the common bracket with the lowest exponent if it exists. You take those out, and then 4 leftovers in bracket. Whatever is left over, you leave in brackets. If you take out a positive, all brackets retain the same sign. All bracket terms will be having the same sign. They will have the same sign as the original expression. Same sign as original expression. But guys, whenever you take out something that is negative, rest assured that inside the bracket, the terms will change. Inside bracket, the term signs change. All of them. Okay? That's something to note, and that is noteworthy. Okay? Then 5. Okay? You check after leaving whatever is left over in the bracket. Check if any factorization can still yet be applied. Any factorization can be applied. By that I mean there's a difference of 2 squares, there is sum of 2 cubes, there is difference of 2 cubes, there is grouping factorization, there is advanced trinomial factorization where you have a quadratic trinomial and the a value is not 1, and there's also cases where a is equal to 1, and you look at those different types of quadratic trinomial. Okay, so you have different types of factorizations to look out for. Okay, so we must always check if there's any type of factorization that can yet be done. So look at this. How many terms here? There's 4. There's an even number of terms. Okay, so immediately when I see this even number of terms, I ask myself, sign change rule needed? No. Highest common factor is there? Yes, highest common factor is positive 1. But that positive 1 won't have a significant impact on the terms themselves, but besides make these terms become one term, right? So what we are then going to consider is grouping. Okay, we are going to group. We are going to play the grouping game, right? So what we are going to do is we are going to group in the ratio 2 is to 2. A pair of 2, a pair of 2. Then in each pair, we are going to take out a common factor, a highest common factor. So if you look at this first pair of terms, what is the highest common factor in this first pair of terms? Let me allow you guys in the comment section to go wild. Very good. Highest common factor for the first pair is x. Okay, what is left over inside? You have 4x squared minus 1. Hope you see that. Highest common factor is x. You have 4x squared minus 1 left over inside the bracket. Look at these last two terms. Look at the first term in these last two. The first term in these last two terms is negative. So the highest common factor here, the highest common factor sign is negative, and between 4 and 1, the highest common factor between 4 and 1 is 1. So we're going to take out negative 1. What gets left over inside if we take out negative 1? We get left with 4x squared. Remember, when you take out a negative, the signs change inside the bracket. Okay, what was positive is now negative. What was negative is now inside positive. That's why I was saying whenever you take out a negative inside the bracket, the term signs, they change. But if you take out a positive, look, we took out a positive x. Do you see the term signs? The signs did not change. So be very aware of that, guys, that whenever you take out a positive highest common factor, the term signs don't change. But whenever you take out a negative highest common factor, the term signs, as you see here, changed, you know. So yes, our factorization pairs, very good. Now if you look at how many terms do you have now in the expression, how many terms, guys? Initially you had 4, but with this 2 is to 2 factorization that you did, taking 2 terms factorizing, taking 2 terms factorizing, how many terms do we now have, guys? Do you see? We have 2 terms. And as you ask yourself how many terms do you now have, is there a need to apply the sign change rule with these terms? Not even. Guys, there is 2 terms. X into x with the bracket makes this 1. Remember, bracket means 4x squared minus 1 is 1 term. But the brackets mean multiply, and multiplication only further combines terms. So we have 1 term here. This minus sign separates. We have 2 terms here. So there's 2 terms, guys, not 6. I don't know how you are counting, but if you're saying 6 terms, no, my guy, not happening like that. There are 2 terms. 1 minus sign 2. Okay, be very careful. Otherwise, you are going to jump off the bandwagon. So in these 2 terms, what is the highest common factor? Sign, number, letter, bracket. Okay, number, sign, positive, number, 1, letter, don't have a letter that is common because x here, all right, there's nothing outside this bracket that is a letter. But with the bracket, guys, but with the bracket, yes, terms are separated by plus and minus sign, but distinctly so, hey? So for instance, inside this bracket, yes, inside this bracket there are 2 terms. But remember, when you have a bracket makes these 2 terms become 1. And furthermore, because this bracket is multiplied to x, because brackets mean multiply, the multiplication makes this entire thing become 1 term. And this minus separates. This entire thing is another term. So there are 2 terms here. Okay. So what is the common factor, guys? Sign, number, positive 1. Letter, we don't have a letter. Bracket, we have a common bracket of 4x squared minus 1 for both terms. So we are going to take out the bracket 4x squared minus 1, including the positive one, which you don't see, which is invisible outside here. Guys, the positive one is like God. It is present, but not visible to the naked eye. So you take out the common bracket 4x squared minus 1. What are you left with on the left if you take out that 4x squared minus 1? Okay, what are you left with on the left? 4x squared minus 1 on the left is multiplied to the variable x. So if you take out 4x squared minus 1, you are left with, yes, z. We are left with x on the left. Then what about on the right? If you take out the 4x squared that was there on the right, what are you left with on the right? 4x squared on the right is multiplied with negative 1. So that means we are left with negative 1 on the right. Okay, so that's our factorization going good so far. Then what do? We check inside each bracket, is there any other type of factorization that can be applied? We just completed grouping and taking out a common bracket. We look at each bracket and we ask, is there something else that can be done? This first bracket, we have a minus sign, we have 4 and x squared and 1. Okay, so Z is saying yes, and then she's writing a big DOTS. Guys, what does DOTS stand for? This negative sign is a difference. This 4 is a perfect square, and x squared, because it has a even number exponent, is regarded as a perfect square variable. So the term 4x squared is a perfect square in its entirety. 1 is a perfect square number. So what we have here is a difference of 2 perfect squares. Yes, Miss V, difference of 2 squares. Mushi, difference of 2 squares. That's what dots means. The other type of factorization that can be applied in this bracket. So what we do for this bracket is we open 2 additional brackets just for this one. Then we take the square root of 4x squared, which gives us 2x for our first term in the bracket. The minus sign for the constant means we are going to write down 2 different signs, one positive and one negative. Difference for your last term means different signs inside your bracket. I repeat, difference for your last term means different signs inside the bracket. So the first bracket we write a positive, the last bracket we write a negative. Then we take the square root of 1. What is the square root of 1? Square root of 1 is equal to 1. So we're going to have 1 and 1 there. So how did I get my term, the first term in each bracket? I took the square root of this perfect square, which is 4x squared. The square root of 4 is 2. The square root of x squared is x. So that's why we have 2x at the first place position in each bracket. Then the square root of 1, we have 1 in the second term of each bracket. Then we drop that x minus 1 next door. Can we factorize any of these brackets any further? No. Do we have any like terms in each of these brackets? No. So therefore we end our factorization right there. This, guys, is a 3-in-1 factorization, if you want to call it that, 2-in-1 if you want to call it that. And this basically is a type of factorization that is what we call complex procedure. Level 3 questions, guys. Okay, so factorization can be basic, but if we add another ring or level of difficulty, we enter into the complex procedure type questions. We call these level 3 questions because they have a complex procedure. All right. Once you factorize once, most people would think that grouping, we're done with grouping, we are finished, and then they end right there. But then they don't check, can I factorize anything further in each bracket? And that's where we see, 4x squared minus 1 can be factorized further. So we then complete the factorization so that we do not sabotage ourselves from getting the appropriate marks. So you would get 1 mark here, 1 mark here. the mark here for taking out the common factor bracket, and then of course you get a final mark, guys, for making sure that you do the difference of two squares for 4x squared minus 1. Okay. Isn't that beautiful? I think you know that's beautiful, and what a nice feeling to get all the marks. But what a sad feeling to maybe not get that last and final mark because you ended right there. So please, guys, when we do factorization, let's always check at the end, is there anything more that can be done, so that we do not lose any marks that are due to us. Does that make sense? Guys, I hope it makes sense. Hope it makes perfect sense, because when it does make sense, you and I, grade 10s, will be flowing into level 7 mode district. Level 7 district will be a district that will be attending, you know, in every test. So let's look at another question here. 16a cubed minus 2b cubed. All right, 16a cubed minus 2b cubed. Right, so let's write down the question. It is also saying factorize. So if we look at this question, what are we seeing? What is the common question we ask ourselves before we factorize? The first question we always ask is, how many terms in the expression? So when you look at this, how many terms do you see? How many terms do you see in the expression? Hopefully you guys can count nicely and you can see the terms that we see in the expression, my beloved grade 10s. Okay, very good. Han Auntie, thank you. You got 2 terms. 2 beautiful terms. They are beautiful, these terms. There's 2 of them. Yes. Next question. Is there a need to apply the sign change rule? No. Next question. Is there a highest common factor? And remember, when we take out highest common factor, we are thinking of the sign, the number, the letter, the bracket. Sign, the number, the letter, the bracket. Highest common factor sign, the first term is positive, so our positive sign is the highest common factor we take out. Okay, that's the sign that we are going to take out. Positive sign, positive number, 16 and 2. Highest common factor between 16 and 2 is 2. Is there a letter that we are going to take out, which is a highest common factor? A cubed and b cubed, is there a letter? Not even, guys. There's no letter that we're going to take out there, so there's no highest common factor letter. Bracket, is there a common bracket somewhere maybe that we are not seeing? Definitely not. So that means, guys, it's SN today. All right, just sign a number. So we take out positive 2 and then we wait. What is inside? 2 times what is 6? And then the a cubed, we drop it inside as well as a leftover inside the bracket. 16 divided by 2 is what? Or what is 2 times? 2 times what gives you 16? So we know we're going to have 8, but 8a cubed in its completion, right? Okay, good job, guys. Good job, good job, good job. Then 2 times what is negative 2b cubed? Okay, so we already have 2 out. What do we need inside for the second term inside the bracket? Of course, we're taking out a positive, so there's no change of sign that's going to be happening there. Signs are remaining the same. So yes, guys, we have a negative b cubed. Thank you, guys. Very good. Once we do this, we get the mark for actually doing highest common factor factorization accurately. Then we look inside the bracket. Remember, is there any other type of factorization that can be performed inside the bracket? And if there is, we need to identify that type of factorization and then do it. If there's not, we end the problem. We end right there. Okay, there we go. Mushi, difference, okay, of cubes. Okay, so Mushi, you call it docs. I call it DTC, difference of 2 cubes. All right. Okay, so you say it's docs. Okay, I love that too. Difference of cubes, that's fine. All right, so let's just adopt that acronym, because some of you are flowing nicely with docs. Okay, Trapstar Kin, do simultaneous equation for what? For grade 10 or grade 11? All right, and maybe you can just send me that You can just do a top up there on my roses with the gifts on the roses, or if someone else does do that, I think 15 more roses adding to that tally of 1,000 will basically put me at a place where I can just divert and go and answer directly your question on simultaneous equations. If you have any requests, guys, you can just drop a gift. You'll see. Drop a gift. You'll see me. Just contribute to my life goal. Then I will stop the tide for you. But if not, I'll just continue with doing what I have planned. Okay. So if you want me to turn the tide, just do the right thing. Contribute to my life goal, and I'll definitely do that thing. Life gift goal. So this is a difference of 2 cubes. Okay. Trapstar, if you wait long enough in the life, it's coming up. It's one of the problems I'll be doing later on. Okay, it's just that I'm doing expressions now. So you can wait or you can gift, and you can go directly if you contribute immensely to my life goal there. You can see my life goal there. Okay, so 8a cubed minus b cubed, guys. All right, so first and foremost, let's first start with the sign. If there's a negative sign for our difference of cubes, then we know for our binomial bracket, if there was a negative, we put a negative here as well. It's as simple as that. If there was a positive there, we put a positive here. Okay, we must make sure that these are perfect cubes. 8 is a perfect cube. If you apply a cube root to 8, it is 2. If you apply a cube root to a cubed, it is a. If you apply a cube root to b cubed, it is b. So these are really perfect cubes, because in order for you to apply difference of cubes, the terms must be perfect cubes. 1 times 1 times 1 is 1. 1 is a perfect cube. 2 times 2 times 2 times 2 is 8. 8 is a perfect cube. 3 times 3 times 3 is 27. 27 is a perfect cube. All right. So I hope you guys kind of get a feel of what we mean by perfect cube. 4 times 4 times 4 times 4 is 64. So 64 is a perfect cube. All right. 5 times 5 times 5 times 5 times 5 times 5 is 125. 125 is a perfect cube. So for numbers, those are the perfect cubes we are talking about. For letters, guys, any letter which basically can be divided by 3, that has an exponent that can be divided by 3, and when divided by 3, that exponent leaves a positive integer, then we know that that is also a variable that is a perfect cube. Okay. If that particular exponent can be divided by 3 and leave an integer value, then we say that is a perfect cube variable. So that's how we identify perfect cube variables as well. So please, guys, if it's a difference of 2 cubes, you can actually factorize using cubic factorization. If it is a sum of 2 cubes as well, you can factorize using cubic factorization. So with the difference, this is how it works. For the signs, your first bracket is identical to the sign that is found in between the 2 terms. So if this was since this is negative, my first bracket will be negative. If this was positive, my first bracket would also be positive. Now the last bracket will have 3 terms, and this is how the sign combination is whenever we have a negative, and this is always the case, guys. So you're going to write negative for your binomial bracket, and then for your trinomial bracket you are going to write plus plus. It's always the case, guys. This is always how things are. Negative plus plus. If you have a negative sign, it's always negative plus plus. Now I can almost hear someone saying to me, sir, what if we had a positive? Let's say we had the same question, but this time round it was 16a cubed plus 2b cubed, and you took out the highest common factor, which is positive 2, and then now you are actually going to apply cubic factorization to the sum of 2 cubes. Sum of 2 cubes is also factorizable, just like difference of cubes is factorizable. But guys, remember, dots, difference of 2 squares, it's only the difference of 2 squares that is factorizable, but the sum of 2 squares is not factorizable. So let us not make the mistake of thinking just because the sum and the difference of cubes is factorizable, that maybe the difference, though it's factorizable, that it also means that the sum of two squares is factorizable. No, guys, the sum of two squares is not factorizable. So the sign combination, if it was a sum of two cubes, since this one is plus, this is also going to be plus. Okay, remember I said here to you guys that if this is minus, then it means that the first bracket is going to be minus. But then the sign combination for the trinomial is plus plus. It's always the case, guys. It doesn't change. It's always the case for all problems at all times. It never changes. Now, if we had a plus, the sign combination works this way. You have a positive, that means your first bracket is also going to be positive. But then your last term, though also positive like your sum, your difference of cubes was, your middle term is going to be slightly different and it's going to be negative. So the sign combination for when you have plus is always going to be plus minus plus. The sign combination when you have a difference of two cubes is minus plus plus. I hope you get this combination. So for a difference, minus plus plus. For a sum, plus minus plus. For a difference, minus plus plus. For a sum, plus minus plus. For a difference, minus plus plus. For a sum, plus minus plus. Then everything else that we do is the same for both. The only thing we need to always sort out is to just sort out the signs. Plus, so if it's a sum, it's plus minus plus. If it's a difference, it's minus plus plus. Now the rest is the same. You want the first term, okay? So what you do is you take the cube root of 8a cubed. So that means the cube root, you can split these, of 8 versus the cube root of a cubed. The cube root of 8 is going to be equal to 2. You can use your calculator, it will give you the answer. The cube root of a cubed is a to the power 3 divided by 3. So that basically means 2a to the power 1, which is 2a. So here, as the first term in each bracket, we are going to write 2a, because the cube root of the first term, okay, the cube root of 8a cubed is 2a. Okay, so there 2a occupies the first term in the binomial bracket. Then now you are going to take the cube root of the first term. So you're going to say the cube root of b cubed. The cube root of b cubed, guys, is going to be b to the power 3 over 3. When you remove the cube root, this exponent 3 belongs in the numerator. This 3, that is the cube root 3, belongs in the denominator. Then you say 3 divided by 3. What is that? 3 divided by 3 gives you 1. So that's why you say the answer is B. So in the second position of the bracket, you are going to have the second term inside the bracket being B. How did you get 2a? You took the cube root of 8a cubed. How did you get b? You took the cube root of b cubed. Guys, you do the same thing here. Cube root of a cubed, we know it's 2a. Cube root of b cubed, we know it's b. You see, so everything else that you do after the signs have been sorted is no different from what you do from the other one. Then, how do you get the first term? Okay, how do you get the first term inside the trinomial bracket? How do you get the first term? Okay, 2a here times what gives you 8a cubed? 2 times what gives you 8? Okay, in other words, what's 8 divided by 2? Right, that is 4. A times what gives you a cubed? All right, or if you have 1a taken out, you need 3. How many more do you need to add? Okay, so it's a squared there. Okay, so that's how we get the first term in the other bracket. What about the last term? B times what gives you b cubed? That's b squared. All right. Now, the trick is getting this middle term, right? And it's simply this: the product of the terms in your first bracket. And you just ignore the sign, guy. Ignore sign. The product. What does product mean? It means the multiplication of these terms. What is 2a times b? That's all I'm asking. Forget about or ignore Mr. Sign. Forget or ignore the sign. Ignore the sign, guys. What is 2a times b? Yeah, it is 2ab. And that's it. Guys, we are done. We are done. We look at this bracket, any other factorization needed? No. You look at this bracket, any other type of factorization needed? Not at all. Any like terms that you see maybe in this bracket? No. Any like terms here? No. Because if there were, we would add those like terms and then we'd simplify each bracket. But we don't have any of that, so we end right there. Guys, you do the same thing here. 2a times what is 8a cubed? It's 4a squared. How do you get the middle term? You multiply these two, you get 2ab. B times what is b cubed? Hi guys, it's b squared. Okay, all right. I hope it makes sense. So this is basically how we factorize a cubic. All right, whether it be difference of cubes or sum of cubes. The only thing I think is a complication here is just the sign. But once you've mastered the signs, you saw what I did, guys. The sign combination is always the same. So for a difference of cubes, okay, it's always going to be minus plus plus. But for a sum of cubes, it's plus minus plus. Then everything else is the same. How do you get this guy? You take the cube root. How do you get this guy? You take the cube root of this guy. How do you get him? You square this first term. How do you get him? You square this last term. How do you get him? You take the product of these two. Don't mind the sign. And that's it. That's it, guys. It's as simple as that. Okay, let's go back to our paper. Our paper is crying for us, eh? I look at you guys looking at the beautiful screen there. Hey. Yeah. Let's go. Let's move. Right, I think we have these following questions now to look at. Beautiful questions, by the way. Might I add myself? Simplify. Negative 12x squared plus 24x over negative brackets minus 2x brackets to the power 4. Right, let's look at this. Very interesting question. Division. Now we are looking at the division of expressions. Okay, division of expressions. Negative 12x squared plus 24x over negative into negative 2x all raised to the power 4. We are asked to simplify. Okay, so if we look at the expressions at the top, okay, in questions like this, when we have a division of expressions, we need to always do this. Firstly, 1, we look at the top, the numerator, and we ask ourselves the common fundamental question, which is how many terms in the expression? How many terms? And then we apply the golden rules of factorization because we want to check how many terms. We can see there's 2. So therefore that means we need to then think about factorization for the numerator. So how many terms do we have? There are 2. And since there are 2 terms, is there a need to apply the sign change rule? No. Is there a highest common factor? If there is, we go ahead and we take it out. So here we look at the top with the intention of factorizing. All right, and when we have the intention of factorization, then it means we ask ourselves those golden rule fundamental questions so that factorization can happen completely. So this numerator term we are going to take out the highest common factor. Guys, what is the highest common factor? Negative 12x squared plus 24x. What is the highest common factor? Does it exist? What is it? All right. Be very careful. In the numerator, what is the highest common factor? We have a negative 12x. Okay, this is a negative 12x squared plus 24x. Yes, Ruben. Okay, be very careful. Remember, when we take out the highest common factor, we take it out according to the sign, the number, and the letter. And remember, as I said, the sign of the highest common factor is always the sign of the first term. Okay, so we are going to take out a negative sign because the first term is negative. All right, then highest common factor number between 12 and 24. So between 12 and 24, the highest common factor number, the number that goes into 12 and 24, that is the highest, is 12. Then between x squared, we're looking at the letter now of the alphabet, x squared and x, we look at the common variable that has the lowest exponent. So we are going to take out x, not x squared, as the highest common factor. Okay. Then once we've taken out the highest common factor according to the sign, number, letter completely, we open a bracket, we write now what is left over. Remember, if you take out a negative sign inside the bracket, the sign terms are going to change. The signs will change. So this first term was originally negative, but now inside the bracket, we are going to have something that is positive. It's going to be a positive x. All right. And then on the other side, it's going to be a negative. Remember, a negative times what gives you a positive? It's a negative. Okay. But then you have 24, you have 12. 12 times what is 24? Or what is 24 divided by 12? That is 2. The x that is there is the one that we took out, so we don't have to worry about that. Guys, let's make sure that our factorization is on point. It should be though, because if we have been factorizing and we've been doing it accurately, we know how to factorize highest common factor, we know how to apply dots, we know how to do trinomial factorization, we know all the types of factorization. At this stage, when you are doing these questions, your factorization skills that are 100% mastered are needed here. We can't afford to be doing funny things here. Okay, so for the two terms, we factorize. We go now to the denominator. We would also look at the denominator at the bottom with the intention of factorizing, but we can see here that we don't have more than two terms. We have one term, right? So all we need to do with the denominator is simply simplify what we have in the denominator. So we look at BODMAS. This is the bracket. We have an exponent outside, and then there's a negative sign. So this negative sign needs to just wait, because BODMAS says brackets first, then O means orders, and orders mean exponent. So we look at the bracket and the application of the exponent and allow the negative sign to just wait a second whilst we take care of bracket business. Bracket followed by exponent business. Go ahead, guys, BODMAS. Brackets. O means orders, and order means exponent and roots. It's exponents and roots. So our priority is the bracket with the exponent. This negative sign is going to be multiplied. Remember, multiplication comes later in BODMAS after orders or exponents and roots are applied. Division and multiplication come later. So that's why the negative needs to wait for a moment here. Let's apply the even exponent to the single term that is inside the bracket. If you apply an even exponent to a negative sign, what happens to the negative sign? Apply a even exponent to a negative sign. What happens to the negative sign, guys? An even exponent applied to a negative sign. What happens to the negative sign? Does it stay the same or does it change? If we apply the even exponent to a negative sign, because this exponent, okay, no guys, if you apply the even exponent to a negative sign, it becomes positive. Okay, that's a rule you should have learned in grade 9. Okay, if you have an even exponent, when you apply it to a negative sign,
the answer is a positive one. But if you have a odd exponent that is applied to a negative sign, the sign remains the same. So please guys, these are basic things that you need to know, mathematical basics, right? Well, thank you so much, Z. I actually omitted to thank you there for the gift. I saw that you did send me a rose and you awesome. Thank you so much there. Okay, apply this even exponent to a negative sign becomes positive. Then not only apply that to the sign but also to the number, because it's one term. So when there's one term, you can apply the exponent to the sign, the number. Remember, the number will be 2 to the power 4, which is 16. And then you apply the even exponent of 4 to x, which is going to give us x to the power 4, because that's 1 times 4, which gives us x to the power 4. Okay, do you see what's happening here? I hope you are seeing what's happening here, guys. Now, what I'm going to see here is that a negative divided by a negative, into is positive. In the numerator, I have one term. In the denominator, I have one term. The negative divided by negative gives me a positive. So I'm going to actually just now deal with two positive. The numerator that's positive and the denominator that is positive. Now I can actually simplify, the number, because there's one term at the top, there's one term at the bottom. This 12x has a relationship with the bracket of multiply. This 16x to the power 4 is divided. This 12x is divided by 16x to the power 4. Okay, the terms in the denominator are not separated by a plus and a minus sign, so cancellation can happen. 12 and 16, guys, there's the highest common factor here, right? What is it? Okay, 4. 4 goes into 12. How many times? 3. And then 4 goes into 16. How many times? 4 times. Then the x and the x to the power 4. This x and this x will cancel. All right. But when we cancel here, we are left with positive 1 in brackets into x minus 2. Here at the bottom, there were 4 of the x's, but now we cancelled 1. So that means we have 3 of them. All right. So now what are we left with, guys? 3 into x minus 2 over 4x cubed. And in all honesty, we can write this as 3x minus 6 over 4x cubed. We can expand out the numerator, but the denominator we can leave that as it is. So then our answer is 3x minus 6 over 4x cubed. We cannot cancel this x and this x because we do not cancel across an addition and a subtraction sign. We could cancel here with the x to the power 4 and the x because this x was outside the bracket and it had a relationship with the bracket of multiply. So that's not cancellation, that is across an addition or a subtraction sign. But here, this 3 and this x are multiplied, but they are across a negative sign. This 2x, this 4x cubed, we cannot cancel this x and this x because we don't cancel across an addition and a subtraction sign. So we leave the answer at this stage. All right. That is what we call simplification, guys. Simplify. We simplify by going through factorization, all right, and then being able to get to the answer in that way. Okay. It's weird is saying, okay, yeah, it's weird. I guess you're following your name quite well. Yeah, but maybe you should look for a live to really follow your name well, not here, because you are kind of disrupting. And I don't know if that is really kind of you, and stuff. And maybe you don't care, but maybe you should. Okay, maybe you don't care. Yeah, it's Mo. How's it, buddy? I see you there. I see you. Can see that's the exact same person that I was definitely communicating with there. Okay, you actually posted on my recent post there. wanting the trig. Okay. There's always a weed in every house. I'm Manzi. Oh my soul, this guy. Okay, I think I'm gonna have to mute and block Mr. Weird, because I think he's gonna prove to be a nuisance in this live if I let him continue with his weirdness. I think he is finding entertainment, so I'll allow him to comment one more time, and if he does, I'll block him if he comments sort of like out of the way. Right, and that's not too because I hate him or anything, it's just that he is proving to be a disruption in the comment section. All right, so let's look at this, guys. Then we have 9 minus 4 over x squared in brackets. It's divided by x cubed over 3x minus 2 all raised to the power negative 1. Okay. Oh, okay. No, I see. So, Tiamo, does that mean you guys have actually started and completed trigonometry, or are you like halfway there? Okay, it's just that like I'm gonna do this now. I'm answering some questions here. I'm gonna from expressions and simplification with exponents, I'm going to be moving to equations, and then I should be done in the next few. I'll see if I can't factor in a little bit of what you had asked in that YouTube video. Okay, so 9 minus 4 over x squared divided by this to the power negative 1. Now guys, first and foremost, we can see, guys, that there are brackets here, so in our heads BODMAS is also crying very hard. All right, yeah, because when we look at something and BODMAS is something we can look at, then we need to not forget BODMAS is very important, guys. Brackets, O means orders, which means exponents and roots. All right, D means division, M means multiplication, A means addition, and S means subtraction. So we do have brackets here, we have division, okay, and we have exponents here. Okay, yeah, so that's very important here. So what we have here is a mix of a question that encompasses both exponents, division, and addition of fractions, and we are required to do what in this question? To simplify. Okay, so I am thinking of BODMAS, and as I think of BODMAS, I'm like thinking brackets. But before I jump into that, I remember something here about division, that there's a rule called the KCF rule. All right, KCF, and then meaning we keep the first fraction, we change the divide to multiply, we flip this fraction. Okay, but remember also, before we rush into division, there is this idea here that whenever you have a negative exponent, you can flip this fraction and then change the exponential sign to positive. So I'm going to, according to BODMAS, first start with the exponent, because remember BODMAS says brackets, exponent. So let's start there. Let's do things in order. 9 minus 4 over x squared divided by, we'll come back to this. Let's flip this thing to 3x minus 2 over x cubed. We change the exponential sign that was negative to now positive. Does that make sense? That's step number 1. Obviously, I think they would definitely give me a mark for this, wouldn't they? Okay, then 9 minus 4 over x squared. Okay, I keep this, I change the divide to multiply, and then I flip the fraction again. It's almost as if like I'm doing this is for the change in the division to multiply and the flipping of the fraction to x cubed over 3x minus 2. Do you see, guys, what happened here? Right, so here I applied this idea. A to the power b raised to the power negative n can be written as b over a to the power positive n. There's a rule of exponents that says that. So this idea of brackets with your exponents here is what I applied for changing this bracket to this. The exponent that's negative changed to positive, and I flipped the fraction. Then I moved on to the division KCF rule, changing the divide to multiply. Okay, this KCF, not KFC, guys, KCF means keep, change, flip. KCF. So this is what we applied here. Okay, so we've just applied KCF there. Yeah, I know KFC though like sounds really good roundabout now. I think we could really enjoy maybe a Streetwise 2 or any other, you know, funky meal that is available. KFC would be really great. So I think your change of meal, we change the sign of divide to multiply, and then we flip our burgers. Like, yeah, we flip our burgers. No, I'm just kidding. We flip the fraction. So anyways, now that we've done that, now I think we can then focus back into this problem. We have 9 minus 4 over x squared. Inside this bracket, let us deal with what is inside. Guys, this is a typical subtraction of two fractions. This is 9 over 1 minus 4 over x squared. Okay, now when you have two fractions, we need what we call the LCD. So between 1 and x squared, we know that the LCD is x squared. So what do we do if we know that the LCD is x squared for this? All right, now I know some people for two fractions use this rule. It's like the butterfly rule. Okay, and it works, right? Take the x squared, you multiply by 9, you get 9x squared. You take the 1, you multiply by 4, you get negative 4. You take the 1, you multiply by x squared, you get x squared. And that completes that addition or subtraction of your fractions, just like that. Okay, I know that this here is the same thing as finding the equivalent fractions of 9 over 1 minus 4x squared. You would basically multiply, if you know the LCD is x squared, you would multiply by 1 by the x squared, but what you do in the bottom, you do at the top. So that's why you get 9 times x squared, which is 9x squared. Then this side, you already have x squared, which is your LCD. So you just times by 1 and times by 1 at the top, which is why you get 4 at the top. But that is all over what? The lowest common denominator, which is common, which is x squared. And you will remember the rule about addition and subtraction of fractions. You can only add and subtract fractions there in the numerator if the denominators are the same, which is why we use the LCD to form equivalent fractions that have that lowest common denominator, which is x squared. Okay, so to form x squared here, you multiply by x squared at the bottom. Then what you do at the bottom, you do at the top, which is why 9 has now been multiplied by x squared. Here we already have x squared, so we just multiply by 1, multiply 1 at the top as well. So we have that 9x squared minus 4 over x squared times x cubed over 3x minus 2. Now guys, what we have here is a typical multiplication of two fractions. When we have that, we look at the numerator and the denominator of all of our fractions and we factorize if possible. That's what we do when there's multiplication and division of fractions. We look at the numerator and the denominator of each fraction and we factorize where factorization is possible. So let's look here at this first fraction. We have 9x squared minus 4. What is this, guys? Can we apply any type of factorization here with 9x squared minus 4? I am asking you guys, you tell me, is there any type of factorization that can be applied there in this numerator? 9x squared minus 4. What do you guys see? There are two terms in the numerator. Okay, these two terms, what do you see? All right, is there a highest common factor? Yes, there is, it's 1, but I mean, it has no significance. Furthermore, what do you see? This is a difference, guys. Good. Okay. And then 9 is a perfect square number. How do you form 9? Why do we call 9 a perfect square number? Because a perfect square number is a number that is formed by multiplying a particular natural number by itself. What is that natural number that you multiply by itself to get 9? It is 3. All right. So therefore, that's why we say 9 is a perfect square. X squared is a perfect square because a perfect square variable is a variable that is raised to an even number. What about 4? Is 4 a perfect square? Yes, it is formed by multiplying a natural number by itself. So that means there at the top, me and you is going to open 2 brackets. The negative sign means different signs in our bracket. Negative constant, negative last term means different signs inside the bracket. Then what do we do, guys? We take the square root of each term. So what is the square root of 9x squared? Okay, Tsiamo has just helped us out. Dimples has already written the entire answer. Hopefully all of you understand what should be done. The square root of 9x squared is 3x. So you write 3x for each bracket. The square root of 4 is 2. So you write 2 for each bracket. So you have 3x plus 2 and 3x minus 2, and there's no further factorization you can do in each bracket. That's all over x squared. We multiply that with x cubed over 3x minus 2. We put a bracket around the 3x minus 2 to show that we've taken out a highest common factor of 1. From 2 terms, now we have 1, which is 3x minus 2. The highest common factor 1, which we don't see, which is invisible, is outside. Then, after factorizing everything that is possible, we cancel common things top to bottom. And we do it once. Okay? Okay? We cancel common. And when we cancel, guys, it's always top. If something at top is common to something at bottom, we cancel. Okay? So if we look here, at 3x plus 2 and 3x minus 2. Thank you, Zama Ngane. Yo, Zama. You guys, you make me happy, man. Thank you for the heart, me, Zama. You know? Yeah, thank you. I really appreciate it, guys. Thank you, Zama. Zama, me appreciate you. Thank you. You are ngangering me, you know? You are ngangering me as I teach. Yeah, just following that surname. You are ngangane. You are ngangering me as I teach. Thank you. Appreciate the gift. The heart me. Right. So 3x plus 2 into 3x minus 2. You can see multiplication there over x squared times x cubed over 3x minus 2. Guys, 3x minus 2 is common to another 3x minus 2. At the top, at the bottom, at the top, at the bottom, we are saying 3x minus 2 divided by another 3x minus 2 leaves us with 1. Okay, we are just left with the number 1. Okay, then we have x squared and x cubed. Come on, guys. You cancel 2 of these x's here. There's 3 of the x's there. But when we cancel 2 here, that means all 2 are gone. We are left with 1, the number 1. But here we cancel the 2 that we cancelled from the bottom. We are left with a single x. So when we cancel, we are left with a single x there at the top. So now, with what has been left over, we take this 3x plus 2, we are going to multiply it with x horizontally. Okay, multiply all top and all bottom. Multiply all top, multiply all bottom. Once the cancellation has been done, you multiply all top, multiply all bottom. So 3x times x into, so we are going to say it's x into 3x plus 2 over This is 1 times 1, which is 1. But remember, guys, when 1 is in the denominator, it is not significant. When 1 is in the denominator, it's not significant. So we can say 3x squared plus 2x is our final answer, and we leave it right there. Okay, simplified. Okay, so guys, take note, there's a lot of things we did here. We first, according to BODMAS, looked at the brackets. Okay, for this bracket we can deal with independently what is inside. With this bracket we can deal with independently what is inside. So what we do now is that brackets are followed by O order, which is, orders mean exponents. So this is a negative exponent. There's a law that we know we can apply. A over b to the power negative n can be written as b over a. We flip the fraction to the power positive n. The sign changes on the outside as an exponent. We flip the fraction. Then remember, there's this divide sign which changes to multiply. We're using KCF here. Keep this first fraction, change this sign, flip the fraction again. Because of the change of divide to multiply, we got x cubed over 3x minus 2. Then, when we are at this stage, we could see that there's another bracket to be dealt with. This is a subtraction of 2 fractions. Okay. Then with that, we simply are able to get what, guys? We're able to form our equivalent fractions using the lowest common denominator. We could see between 1 and x squared, our lowest common denominator is x squared. So what do we do to 1 to get x squared? We multiply by x squared. What we do at the bottom, we do at the top. We multiply by x squared, we get 9x squared. Here we already have x squared. We don't have to multiply by another variable, but just by 1. We multiply by 1 to get that same LCD, which is x squared. We do the same at the top, so we have 9x squared minus 4. Molly Swag, thank you so much. I really didn't believe myself, but does lives actually help me a lot. Okay, no man, wow, that's sweet. All right, this is like a galaxy worthy comment. Thank you so much, really appreciate your comment there, dearest Molly. Didn't know that you were watching my lives every morning. I wouldn't have known, eh? Some of you never let me know, hey? Some of you never let me know. You know, it was interesting that a few weeks ago, I don't know how this person actually knows that it is me that is doing the live. I don't often show my face, so I don't know how this person knew. But in a particular school where I actually tutor, someone actually came up to me, I think it was after like a session, and they were like, sir, I'm that person that used to comment a lot in the comment section when you were doing grade 9 lives last year. I did very well in GEC. You really helped me out a lot. And I was like, huh? But how do you know it's me? Like, you know, it was crazy. And yeah, so I really appreciate it when things like that do happen. Like, it's kind of sweet. It touches me a lot. So thank you. I really appreciate it. And thank you for your comment, Molly Swag. You have no idea what it means to me that you can actually state that all glory goes back to God. All of it, you know, I'm just merely an instrument. So thank you so much. Anyways, coming back here, guys. So here, you know, we have 9x squared minus 4. But we can see here, all right, your unique voice probably, sure, eh? 9x squared minus 4. Here at the top, we factorize, guys. Look at that. We factorize, okay? X squared at the bottom, okay, not factorizable. X cubed, not factorizable. This here, we just put in brackets, okay, to show that the highest common factor 1 we've taken out. Okay, that allows us to be able to cancel top and bottom what's common. So that and that cancels, because 3x minus 2 divided by 3x minus 2 is 1. Okay, then x squared, there's 2 of them, there's 3 of them. So the 2 go, we are left with just the number 1. The 2 also go here, but then we left with 1x because 2 have been cancelled. Does that make sense? We left with a single x. So that x gets multiplied with 3x plus 2 because we multiply all top after cancelling and we multiply all bottom after cancel. So x into 3x plus 2 gives us 3x squared plus 2x because we distribute the x into the 3x and the 2. And then the 1 in the denominator is just insignificant. We don't have to write the 1 if it's in the denominator. But if it's in the numerator, guys, that 1 would have been there in the answer, 1 over 3x squared plus 2x, had that 1 been the one left over in the numerator. Let's never forget that. Okay, nice question, eh? Very nice question, that one. Very beautiful question. Okay, let's go down. You got another question here. Simplify. 5 times 45 to the power x over 9 to the power x times 5x, 5 to the power x plus 2. We've got a exponential expression there. We need to simplify it as all multiply and divide. There's no addition and subtraction, so that in and of itself is a beautiful clue. All multiplication and division, there's no addition between the bases or subtraction. Okay, all right, so when we have an exponential expression like this, what do? 5 times 45 to the power x over 9 to the power x times 5 to the power x plus 2. Okay, so 2 ways you could do this is to first write all of these bases into their prime base. That's one way to do this. So let's look at that way, converting all our composite bases to prime bases. Composite to prime. So 5 is already a prime base. I'm going to just show you that the exponent is 1. Okay, because oftentimes people omit to know that the exponent of 5 is actually 1. We change 45, we put it in brackets, composite number, which is 45, to a prime base. 45 can be written as 3 squared times 5. Remember, 3 squared is 9. 9 times 5 is 45, all raised to the power x, over 9 can be written as 3 to the power 2. Okay, guys, if you don't know how to convert this, you can just simply use your calculator, and you say in your scientific calculator, your Casio calculator, 45, you press in the number, you press equal, you press shift, you press fact, it will give you the breakdown of the composite bases. Same thing with 9, 3 to the power 2. You just say 9 is equal to shift fact, it will give you that. The 5 to the power x plus 2, the 5 is already a prime base. Okay, now we are going to expand this one. So we have 5 to the power 1 times 3 to the power 2 times 5 to the power x. We can just say 3 to the power 2 times x, which is 3 to the power 2x. We distribute the x to the 2, and we distribute the x to the exponent that you don't see, which is 1 for the 5. 5 to the power x over. Do the same thing here. Applying law number 3 of exponents, we multiply 2 times x times 5 to the power x plus 2. Okay, so law number 3. After changing composite to prime base, we apply law number 3. Law number 3, guys, has to do with this. A to the power m raised to the power n is equal to a to the power m times n. Okay, it's that law. Okay, coupled with this law, that if you have a multiplication of different bases, you distribute the exponent by multiplication to each respective base's exponent. Okay, that's law 3 and law 4. You apply that. Then after that, you apply law number 1 and 2. What does law number 1 and 2 say? Law number 1 says if you are multiplying same bases, you keep the base a, you add the exponents. That's law 1. Law 2 says if you are dividing same bases, this m is the exponent of the base a at the top. So you are going to say m a, keep the base, you subtract the exponents. This m is at the top, it retains its exponential sign. This n has an exponent at the bottom with the base being at the bottom. So when you raise it up to the top, when it changes position and moves from the bottom to the top, the exponential sign changes from positive to negative. So this is a typical thing that we need to take note of. So how many bases do we see? We have base 5 and we have base 3. So we are going to deal with base 5 first and say 5 to the power 1, this one that's at the top. At the top, we retain our sign. Since we are multiplying this 5 and this 5, we are retaining our signs at the top. We are adding x, retaining the sign at the top. We go down to the bottom. Now, when we come to the bottom, we want to take this to the top. What happens to the signs of the exponent? Anyone want to tell me? This 5 to the power 1 plus x, the x plus 2, what is going to be the signs of x plus 2 when I basically combine them with the exponents of 1 plus x? Anyone care to tell me in the comment section? The exponents of x plus 2. Okay, base 5 at the top, base 5 at the top. We are retaining our signs. We are adding the actual given exponents. We go down to the bottom. We want to take these guys to the top. Where do we get plus x as an exponent? G-man, this base 5 and this base 5 are in the numerator. We are multiplying 5 to the power 1 times 3 to the power x times 5 to the power x. The relationship of these bases is multiplication. But because we have the law that says for same bases, when we multiply, we add the exponents. When we are multiplying, we add the exponents. Then I am taking 5 to the power 1 and I am adding it to x because they are being multiplied together and they have the same base. So that's where I'm getting the plus x from, Mr. G-Man. Are you with me now? Now, this 5 to the power x plus 2 needs to also join in the fun. So we say 1 plus x, but then when we take these from the bottom here, what are we going to do to them as we continue with 1 plus x? What are we going to do to x plus 2? Right? Okay, z, very good. We are going to say minus x. So this x, which is positive, when it goes up, it becomes negative. And then this plus 2, which is positive, also becomes negative. Therefore, we have 1 plus x minus x, change of sign, minus 2, change of sign. Because we are applying law number 2 of exponents, division. The n changed sign when it went up. So the x is also changed sign when it goes up. The plus 2 is also changing sign. What if this was x minus 2? The x would change sign, it would be negative. The negative 2 would change sign, it would be positive if this was x minus 2. Because it's x plus 2, x changes sign, it's negative. 2 changes sign, it's negative. Does that make sense? So anything you take from the bottom and it goes up, the exponential sign is going to change as it joins the other exponents for that very same base. So we are done with base 5. We move on to base 3. Base 3 at the top. So base 3 at the top has the exponent 2x. The exponent 2x in the denominator. What happens when we take it up to the top? Okay, this exponent 2x becomes or is okay, negative 2x. All right, so we've applied the laws 1 and 2 very successfully. So from composite to prime base, okay, then to law number 3 and 4, then to law number 1 and 2, and then lastly the addition now of like terms of the exponents. X minus x is 0. 1 minus 2 is negative 1. For base 3, 2x minus 2x is 0. 5 to the power negative 1 according to your laws is 1 over 5. Times 3 to the power 0 is 1. Final answer, 1 over 5. That is our final answer. And it's as simple as that, guys. Okay, 1 over 5. There. Okay, this is one way of doing that question. Someone else who was doing this question, Yes, Tsiamo, very good. The reason why we actually then wrote this 5 to the power negative 1 as 1 over 5 is because, as Tsiamo has said in the comment section, very good, Tsiamo, very, very good observation there. We never want to leave our answer having negative exponents. So we use the definition that says any base raised to a negative exponent can be written as that same base in the denominator if it was in the numerator, with the same exponent, that's just with the sign change, with 1 in the numerator. Okay, so very good. Thank you, Tsiamo, for that beautiful observation. Beautiful observation. Okay. All right, I think we can now move on to the next few questions. Solve for x. Here we are. Okay, we are going to rush through and finish off our questions with a 3.1.1 solve for x, 3.1.2 inequality, 3.1.3 exponential equation, and then 3.2 solve for x and y simultaneous equation. And that should basically be that. Okay, yeah, be that for the beautiful night. And really and truly, you can have these questions written down and you can be doing them a long time, and then by the time I am doing them, you have actually done them and you are sure of what you have written down. Okay, yeah, I mean, guys, this is the kind of questions you should be able to answer, and you should be answering with the utmost confidence. Easy stuff, easy. All right, not even should be blinking too much, So 2x is equal to 5x plus 3. All right, so whenever we have a quadratic, we call this a quadratic equation. Why do we call it a quadratic equation? It's because the variable with the highest exponent has the exponent 2. Okay, so 2x squared, thank you, Z. 2x squared is equal to 5x plus 3. Shalom to you too. 2x squared is equal to 5x plus 3. Peace be with you as well. 2x squared is equal to 5x plus 3. We need to first write this equation in what we call standard form. We write the equation when it's quadratic in the form of ax squared plus bx plus c is equal to 0. We need to get this into the standard form equation. All right, so here all we needed to do was transpose 5x and transpose 3. When we transpose 5x from the right to the left, positive 5x becomes negative 5x. Transpose positive 3 from the right to the left, positive 3 becomes negative 3. Then from there, what do? Factorize. So step 1, standard form. Step 2, factorize. Step 3, 0 factor law. Step 4, our roots, meaning our solutions, the roots of the equation for that particular equation. So if we look at this, what type of quadratic trinomial do we have here? We have the one that where a cannot be 1. So that means we are going to have to apply or incorporate an appropriate method to be able to solve for x here. Now, if you remember this quadratic trinomial we dealt with, all right, and the method that is very much recommended is the AC method, where we take the 2, we multiply it by negative 3, and then we get a what? A negative 6. Then we ask ourselves, what are the factors of negative 6 where the signs are different? Remember, a negative sign means signs are different. What are the factors of negative 6 where the signs are different? Will give me a sum of negative 5. So the factors of 6, we have 6 and 1. We have 3 and 2. Where the signs are different, in other words, where the highest factor is negative. Highest factor here for these two is negative 6, which is 6, which is negative. 3 and 2, we are going to assign negative to 3 because it's the highest. So I mean this one is plus, that one is plus. So which one, when I add together, gives me negative 5x? It is negative 6 and 1. So I'm going to put x and x next to negative 6 and positive 1. And then I'm going to take this pair and replace it with a negative 5x. So let's rewrite this equation and replace negative 5x with negative 6x plus x. Then we subtract the 3. We say equal to 0. So using the AC method, 2 times negative 3 is negative 6. Finding the factors of what? Of negative 6, which when I add together will give me negative 5. That's negative 6 and 1. Those are the factors of negative 6 that give you negative 5 when you add them. It's negative 6 and 1. Negative 3 and 2 would give us negative 1. We don't want negative 1. We want negative 5. So it's negative 6 and 1. So we assign x next door, and then we replace the negative 5x with this negative 6x plus x. There. We apply the grouping method. Okay. The grouping method, highest factor between these two is 2x. So we have x minus 3. Highest common factor here is positive 1. That leaves us with x minus 3. Then we have a common bracket, which is x minus 3. We take it out. And then what's left over on the left? 2x. What's left over on the right? Plus 1, which is equal to 0. Now that we are here, this is factorized. This is the factors we were looking for. A product of factors equated to 0. Now we can apply the 0 factor law, which says if there's 0 and there's factors on the left, you take each individual factor, you equate it to 0. You make each individual factor, x minus 3 equal to 0, 2x plus 1 is equal to 0. Solve each individual linear equation. You take the negative 3 over, x is equal to 3. Then you solve this one. You take the positive 1 over, you get negative 1. You divide both sides by 2, you get x is equal to negative half. So we are done. Solutions, x is equal to 3 or x is equal to negative half. Our factors are there. Our standard form is there. So standard form, factors, our roots. Okay, and we basically followed the steps. Standard form, we factorized, applied the 0 factor law, we got our roots. Guys, it's as simple as that, this thing. Nothing much to it. We ate it. We ate, and it's great. we ate, and it's great. Let's move on to the next one. Inequality. If you have any questions, comment section is yours, my guys. Comment section is yours. Let's look at the inequality. Inequalities, guys, very beautiful questions that we have here. Okay, so first things first, we solve an inequality that is linear like we would solve a linear equation. All right, so let's go. 6x. On the left, we have 2 terms. 6x is on its own. Negative 3, we need to distribute because negative 3 is attached to the bracket x plus 4. Negative 3 times x, negative 3x. Negative 3 times 4, negative 12. Minus 5x less than 0. We collect the x terms. 6x minus 3x, that's 3x. 3x minus 5x, negative 2x. That is going to be less than 12. We take the negative 12 over, you get positive 12. We divide both sides by negative 2. Immediately when we do that, the inequality sign, please guys, must change direction at the very moment when you are dividing by negative. I repeat, the inequality sign must change. If you show division of negative 2, that sign must change at that very step. It doesn't change after we are done. It changes immediately as we basically divide by negative 2, so that the inequality can remain true, not false. So we get x is greater than negative 6. We are done. 1 mark for this, 1 mark for that, 1 mark for the expansion. Okay, that's 3 marks that we are worthy of receiving. 3 marks. So yes, please guys, division by a negative sign changes sign immediately. Division by a negative coefficient. In linear equation, in linear inequality, changes or reverses the inequality sign. Jackie J, I didn't get that one. Okay, so one more time. This is an inequality. What this means, guys, is that the expression on your left is less than 5x, which is your expression on the right. So what we want is the value of x which will keep this statement true. Meaning when you substitute that x value, whatever it is, it must give me a situation where the left is going to be less than the right. I repeat, whatever values of x I choose to substitute in this expression must make it in such a way that the value that I get on the left must always be less than. Remember, this symbol means less than or smaller than whatever value I get on the right when substituting the same value of x. So what you do is you simplify the expression on your left. 6x is a standalone term. Take negative 3, distribute it, you get negative 3x. Take negative 3, distribute it, you get negative 12 minus 5x less than 0. You then add the like terms. What's 6x minus 3x? It's 3x. What's 3x minus 5x? Negative 2x. You isolate negative 2x on your left because this is a linear inequality. So just like linear equations, in linear inequalities, you seek to isolate the value of x, the variable x. So we have negative 2x less than 12. You want to get rid of negative 2. So what do? You divide by negative 2. But guys, here's the thing. The rules in inequalities say that whenever you divide by a negative coefficient in a linear inequality, this inequality sign here reverses or changes direction. This was less than, now it's greater than. So therefore our final answer is x is greater than negative 6. So if you were to take any value that is greater than negative 6 and substitute it here, you would actually see that that value actually satisfies this inequality. So let's just try it out. Let's say negative 5 is a value we substitute. So if it was positive, the inequality will remain. Yes, G-man. If this coefficient of negative 2x was just positive 2x, we'd simply divide by 2. There would be no inequality sign change. You see, that's why I said division by a coefficient in linear inequalities by a negative, because you see that is the sign, by a negative coefficient of the variable in a linear inequality changes or reverses the inequality sign. So yes, G-man, if it was positive, let's say it was positive 2x, the inequality sign would remain that way until the end. It only changes when you are dividing by negative. Hope that's clear. So you get an answer now of x greater than negative 6. So I don't know, that person who said I didn't get that one, I think it was Jackie J. Is Jackie J still here? Or can Jackie J reveal herself by sending me a You're Awesome gift? Okay, Jackie J got it. Thank you very much. Okay. Hopefully you're not just saying that, like hopefully you genuinely got it. Yeah. Okay. Let's look at another question here. 2 to the power x plus 2 plus 5 to the power 2x, 2 to the power x, plus 2 to the power x is equal to 40. Okay, look at this question. Look at the expression on the right. How many terms do you see? Look at the expression on the right before the equal sign. Look at just the expression before the equal sign. How many terms do you see? Yes, Mushi, there's 3. Is there anything that you notice that is of like commonality between the terms? What do you notice between the terms? Something that is the same or similar. Yeah. So what we do here is we split 2 to the power x and 2 to the power 2, okay? Plus 5 times 2 to the power x plus 2 to the power x is equal to 40. Now, on the left, guys, we can see there's something that is common. 2 to the power x, 2 to the power x, 2 to the power x is common for all 3 terms. So we take out 2 to the power x. What do we get left over with here for this term? If we take out 2 to the power x, we are left with 2 squared. Take out 2 to the power x, we are left with 5. Take out 2 to the power x, we are left with 1. And that's all equal to 40. So now 2 to the power x equal to 4 plus 5 plus 1 is equal to 40. 2 to the power x times 10 is equal to 40. Okay. Then what do you do? 10 is the coefficient. So those cancel. We get 2 to the power x, so it's 40 divided by 10, it's 4. 2 to the power x is equal to 2 squared. So x is equal to 2. X is equal to 2. This is a nice exponential equation. Split the base. Highest common factor. 2 to the power x 10. X is equal to 2. Right? And then I think lastly, let's just say, 2 to the power x is equal to 4. So that's 10. 10 marks that would be awarded to our good friend there. And the last question that is in this document that I have before me is this one. Hopefully you got this. But like I said, you can comment in the comment section if you are lost about something, please. Okay, look at these two equations, inequalities. And the only real question I ask is a fraction avoidable? Can we avoid using a fraction here? Can we avoid fractions? Because if we can, let's avoid them. If we can't, then I guess we know how to deal with them. So we can isolate x for equation 3. We get 3y plus 7. That is my equation 3. You took this equation, you made x the subject of the formula. You got x equal to 3y plus 7. Now we are going to substitute x is equal to 3y plus 7 into 4x minus 2y is equal to 8. So x 4 into 3 y plus 7 minus 2 y is equal to 8. Okay, sorry guys, just need to take a break a bit. Yeah, I'm tired. And realize. Okay, so guys, I'm sorry about that. Let me just rewrite this equation again. So this is equation 1. This is equation 2. So since I can see that x has a coefficient that is 1, I'm going to take that equation and I'm going to make x subject of the formula, which means equation 2 is now written with x being the subject, and I'm going to write this equation in terms of y. I'm writing it in terms of y because x is in terms of y. Okay, your second term has a y in it, so we say that this equation is written in terms of y, right? Now, this x can now be substituted anywhere in the other equation. Remember, equation 2 is still equation 3. So now we are going to substitute equation 3 into equation, the one we haven't touched yet, which is equation 1. So that means everywhere where x is in equation 1, we are going to substitute 7 plus 3y where in the place of x. So everywhere where x is, we substitute 7 plus 3y. So let's go to equation 1. there is a 4 followed by an x. In the place of this x, we are going to open a bracket and say 7 plus 3y. Remember, this is 4x, but now in the place of x, what are we going to replace x with? We are going to replace it with 7 plus 3y, the expression. Okay, followed by what? By a minus, followed by a what? By a 2y, equal to a what? To the 8. Now let us solve for the variable we have here, which is y. 4 times 7, 4 times 3y. 4 times 7, 28. 4 times 3y plus 12y minus 2y is equal to 8. What's 12y minus 2y? It's 10y. Okay. Then you take the 28 over. That's negative 28. We get 10y is equal to, what's 8 minus 28? Negative 20. Okay. Then what we are going to do is divide both sides by the coefficient of y, which is 10, which will give us y is equal to negative 2. This is my y value, guys. Okay. Remember, simultaneous equations about solving for y, and then thereafter solving for the other unknown, which in this case is x. Hopefully we are going together, guys, and we are feeling this together. We are not done. If you are lost, say so. Tell me where you are lost. Let me come and find you. Now, you have y. You can now find x. Remember, you formed equation 3. Equation 3 was in terms of y. So x is waiting to be found. Y is ready to be substituted in this equation 3. So we are going to write x is equal to, write 7 plus 3. In the place of y, you write negative 2. Then you solve for x. 7 positive 3 times negative 2 is negative 6. But 7 minus 6, it's 1. Okay. Therefore, x is equal to 1 and y is equal to negative 2. You could write these as coordinate points because this answer is a representation of what we call the point of intersection between two linear equations. In other words, two straight lines. Two straight lines will intersect at a point. Where they intersect, this is the point where x is 1 and y is negative 2. That's where those two lines intersect. It's at positive 1 and negative 2. Okay. All right. So guys, that is basically what I had for you today. Okay, this is what I had for you all today. Hopefully this was jam-packed, and hopefully my grade 10s that are preparing for their March control test are finding value in what we are doing, and yeah, you guys are going to be really doing the most, you know. Yeah, so I don't know if there's any other questions, any other comments, any other queries, any other concerns. If not, I'll be ending the live in a few minutes. But yeah, as we close off, guys, you are more than welcome to support, you know, with an appropriate gift in the for the live. Please, before we depart or part ways, yeah, you are more than welcome to. Yeah, and I really appreciate, guys, the support when it does come. Always appreciate the support when it does come. Okay, guessing no questions. We are all clear. All systems go. Okay. Again. Then without any further ado, let me love and leave you, and yeah, see you again on the flippity flip side. Thank you guys for the follows. I really appreciate the follows as well. Thank you for the likes. 18.7k likes we reached there today for the live. Thank you so much for that, and thank you for everything else that you guys do, making it possible for us to be able to meet and interact in the fashion that we do. I wish you everything all the best. Yeah, if we do allocate marks here, making x or y the subject of the formula, substituting into the other equation, y is equal to -2, x is equal to 1. It's a typical 4-mark awarded question. Okay. Yeah, I think we've already spoken about this. That's 5 marks. Okay. This one was 3 marks, as we've already spoken about it. This one, standard form, factors, roots, both of them being correct. That's 3 marks. Okay. Then, of course, 2 marks for initial expansion, and then the answer. That's 2 marks. Then here, factorization, grouping, obviously, and factoring the first 2 terms, 1 mark. Factoring the last 2 terms correctly, 2nd mark. Common bracket with leftover bracket, 3rd mark. And then factorizing further, difference of 2 squares, 4th mark. So that's a good 4 marks there. Cubic factorization, okay, taking out the highest common factor mark, and then 2, factorizing the difference of 2 cubes for a 2nd mark. Okay, then this one was brackets with 9 minus 4 over x squared with a divide. There was brackets x cubed over 3x minus 2, all raised to the power -1. So the first mark that I will award is inverting the fraction in your bracket, because BODMAS says brackets exponents. Okay, so we could independently deal with this bracket in as much as we could independently deal with what is inside this bracket. So what we did initially was the exponent, negative exponential sign changes, and then the fraction flips. Denominator becomes numerator, numerator becomes denominator. Next step, change divide to multiply. We call that the k meaning keep the first fraction, change the division to multiply, and flip the fraction KCF. We then, inside this bracket, deal with the addition or subtraction of two fractions. Remember, denominators are not the same currently, 9 over 1 and 4 over x squared. So we figure the LCD is x squared. We multiply the denominator by what is needed to get the LCD, which is times by x squared. What we do on the denominator, we do in the numerator. Then same thing with 4 over x squared. What we do in the denominator is times by 1. We do the same thing in the numerator. So then you have 9x squared minus 4 over x squared. Then x cubed over 3x minus 2. We factorize where possible. Denominator, numerator, numerator, denominator. Put these in brackets. We cancel what's common top and bottom. Cancel what's common top and bottom. 2 of those x's are gone. We are left with just the number 1, not that we are left with a single x. No. This is 1 in the place of x squared being cancelled, and then that's 1x in the place of x cubed being cancelled. So then x into that 3x plus 2 gives us 3x squared plus 2x, plus 1 times 1 gives you 1, and that 1 in the denominator is not significant. Then exponential expression, guys. Changing composite to prime bases and putting in brackets, then distributing using law number 3 and 4, law number 1 and 2, applying law number 1 and 2. Same bases you add when you are multiplying the exponents, but when they are coming from the bottom, the sign of the exponents change. Okay, so that was 1 plus x, top exponents in the numerator, negative x minus 2, bottom exponents in the denominator. The sign changes. 3 to the power 2x over minus 2x, that gives you 3 to the power 0, 5 to the power negative 1 is 1 over 5. And the answer is 1 over 5, because a base raised to a negative exponent, we can't leave like that. Okay, so that was just a summary of what we've just done, and I hope you guys are happy with that. Okay, all right, are there any departing last questions before I leave you in peace, guys, so that you guys can sleep? And also, yeah, it is 10 o'clock, so yeah, I don't want to be here with you grade 10s for too long. Nothing else, nothing more, no gifts, no galaxies. I always imagine some random person just bamboozling me with a galaxy, and me just being super happy because I'm like, it's never happened before. It's never happened before. So let's do a match, guys. Let's match these guys. I always wanted to match. Let's see if we can have some double tapping going down, guys, and just like some. I think I'll end this live lesson with a match. Come on, guys, help me out. Let's tap. I've never done this before with this account. I don't think I have. Okay, let's tap. Let's tap hard there. Times 2 gifting points, guys, for the first few 23 seconds, 30 seconds. So if there's anything you can pause it. But if not, just double tap, individual double taps. We have 15 people in the live, so if all 15 of you can double tap, that's like 3 points a piece, which is 45. You get 45 points just from your double taps. Ooh, lazy. Got some lazy tappers. Oof. Okay, now it's fine. Guess we're losing this one. Come on, guys. Where's your fighting part? Where's the spur? Where's the spur? Okay.